Alright, so we'll move on to our next unit, which is waves. And waves are a very important part of physics. Waves are used in our everyday lives, from radio waves to your computers, to your cell phones, to sound and music, which we're going to talk about this unit. And then next unit, we're going to talk more about the other type of waves that you use in electronics. And if you ever go on and study physics in college and study quantum mechanics, waves are the foundation of quantum mechanics. So let's dive into this and talk about waves. So firstly, what is a wave? Well, a wave is a disturbance or vibration that transfers energy through matter and space. So wave is a vibration that transfers energy. Simple enough. And we can describe waves in various characteristics. So the amplitude is the height of the wave, the wavelength, the wave speed, the period, and the frequency. And we're going to dive into these more throughout the video here. So the amplitude is the height of the wave. So where this is a naught, this is the amplitude. Likewise, a naught, this here is also a naught. This is also the same amplitude. So this is also a naught. So the amplitude is the height of the wave, and because it is the height, it is measured in meters, because height is distance. Just like how you measure height in real life, waves are physical, and you can measure the height of them. Okay, another important part of the wave is the crest. The crest is the top of the wave. So the top of the wave is we call the peak, and it's these points here. So a wave travels up and down. It goes down, up, up again, down, infinitely. And at each point where it reaches the top before coming back down, we call the crest. Likewise, the bottom, we call those troughs. So every time it reaches the bottom of a cycle, we call those troughs. Every time it reaches the lowest point of the wave. So as it goes down, it reaches the bottom before going back up. We call that a minimum as well. Okay, the wavelength is the distance between one crest to another crest. So here you have a crest. My marker's not working. So here you have a crest, and then you have a crest here. The wavelength is the distance between one crest to another crest. So wavelength is measured in meters. In the equation here, this is called, this symbol here is called lambda, the one that looks like an upside down Y. And then V stands for wave velocity, and F stands for frequency. So this here stands for lambda. This is wavelength. This is velocity, or wave speed. And this here is frequency. This is wavelength. So the wavelength is what's given by the wave speed divided by the frequency. And on the side here, you see you have a long wavelength and then a short wavelength. Moving on. The wave speed is how fast the wave moves. So it's the velocity of the wave. So wave speed here is measured in meters per second because it's the speed. The equation here is wave speed equals wavelength times frequency. Notice that this is the same equation as before, just rearranged. Because if I want to solve for wavelength, I got to divide by frequency. That means that wave speed divided by the frequency equals lambda. So likewise, wave speed equals the wavelength times the frequency. So this here is wave speed equals wavelength times the frequency. And we're going to do some example problems with this later on as well. Alright, the period of the wave is the amount of time it takes to complete one wave or cycle. And because it is the amount of time, time in physics is always measured in seconds. And the equation for a period is simple. It's 1 divided by the frequency. So T equals period. This stands for period. If you can't remember period, think time. But capital T means period. And it's 1 divided by the frequency. And the frequency is the number of waves that pass a given point in second of time. So how many waves, if you would measure the number of waves passing, it would be the frequency. How many waves pass per second? And the frequency is given by 1 divided by the period. So this is the frequency, and this is the period. 1 divided by the period gives you the frequency. Because it is 1 divided by the period, we call these inverse relationships. So as you increase the frequency, the period decreases. If you increase the period, the frequency decreases. So once again, to reiterate, the crest is the top of the wave, the wavelength is the distance between one crest to another crest, the amplitude is the height of the wave, and the bottom of the wave is called the trough. So there are various types of waves. There are transverse, longitudinal, mechanical, and there's also electromagnetic waves, but we'll talk about that more next unit. We're going to talk about these types, main types, at the moment. So the first two, transverse and longitudinal, explain how the wave propagates versus how it moves. So a transverse wave is a wave that vibrates at right angles to the direction of travel. So if the wave vibrates up and down, it travels left to right. Likewise, a wave that vibrates left to right will travel up and down, for example. So transverse talks about waves vibrating at right angles to the direction of travel. So for example, here you have this water droplet, and it is vibrating up and down because it's coming down, but the wave is traveling left to right. And this is, if you remember math, this is indeed a right angle. Let me make that angle look a little better. There you go, that's your right angle. Opposite of that is the longitudinal wave. So longitudinal wave is one that vibrates in the same direction as travel. So waves that vibrate left to right will transfer left to right, move left to right. Waves that vibrate up and down will move up and down. So sound is an example of a longitudinal wave. We'll talk more about that when we talk about sound. And then the P waves of an earthquake, an example of longitudinal waves. And so then a mechanical wave is a wave that travels through a medium or matter. So a medium is anything that has matter. It's how something travels through. So air is medium. Air has molecules, it has matter. So sound needs air to travel through, which is why you can't speak in space. Water ripples, right? You need water to travel through. They can't travel without water. Any wave that requires some physical medium or matter to transfer is a mechanical wave. And then likewise, the other wave I mentioned is electromagnetic waves. It's a wave that does not require a medium to travel and can travel through empty space. So light does not need a medium. Radio waves don't need a medium, and microwaves don't need a medium. In fact, all these type of waves exist on a spectrum, and they're all technically forms of light. And we'll talk more about that next unit when we talk about light and color. But this unit, we're going to focus on mechanical waves. Alright, from there then, we're going to go ahead and transfer to do some example problems in the next video. Thank you for watching.